we want to do an example showing the distance between parallel lines. And to do that, I've chosen this particular example. So for here, we want to find the distance between the line described by this set of equations and the line described by this set of equations. Now, if you recall, normally the way we would do this is we would say those are my points, so I can call this P, 3, -2, -1, and Q, -1, 3, 0. And then I would say, okay, well, those are my direction vectors. But the problem is that the direction vectors don't look like they're the same vector. So how can we be sure that they're actually parallel? Well, I could say V1 is 6, 9, -12. And V2 is 4, 6, -8. Well, in this particular case, I would need to say, okay, well, if two vectors are parallel, then one's a constant multiple of the other. So what happens if I multiply 2/3 times V1? I get 2/3 times 6, so that's 12/3, which is 4, 18/3, which is 6, -24/3, which is -8. So if V2 is 2/3 V1, then that tells me that those direction vectors are parallel. And really at this point, what this is telling me is it's telling me more about the travel speed. So they are going in the same direction, but this one, if you're using time as your index for t, it tells me this one's going much more quickly over time than that one. Well, that's about 50% more quickly. But nonetheless, since they are parallel, you can think of them doing like that. You know, one of them's getting away from the other, but they're still just leaving a trail behind them that's parallel. So we're still completely able to perform this process. So let's use P and V1 as our vectors here, and Q as our point off that. So if we're constructing that visually, you have a point P, you have V1, you have Q, and then that's the line that it's going across, just to kind of give you a good idea of what we're really going for here. And of course, we're trying to find that distance D. So let's start filling this out. Remember, to do this, we need to find a few quantities. We need to find the directed line segment PQ. So that's going to be -4, +5, +1. And then we already have V1. So that is 6, 9, -12. But we need to compute this cross product. So PQ cross V is there. And we're going to, fill that out. 4, 5, 1, -4, 5, 6, 9, -12, 6, 9. -60i plus 6j minus 36k minus 30k minus 9i minus 48j. A lot of negatives here. So -69i minus 42j minus 66k. It's quite a whopper there, isn't it? So what we need to do is we need to get the magnitude of PQ cross V1. And then we're going to divide it by the magnitude of V1. So let's go ahead and get the magnitude of V1. So that's 36 plus 81 plus 144. And what I already know is I can factor a 9 out of all those. So if I pull a 3 out, that's 12, sorry, a 4 plus 9 plus 16, 3 square root of 29. So I need to get the magnitude of that bad boy. And I didn't pre-compute this because I'm kind of dumb. So I need to figure out what 69 times 69 is. So that's 801. $49.41. $17.64. $43.56. So then that is going to be those added together. So what do we got here? Is 1, add a 1, so that's 12, 16, add a 1, 11, 20, add a 2, 6, 7, 11. So your final answer is the square root of 11,061 over 3 square root 29. And it probably simplifies more than that, but that's what I get for doing this off the cuff.